Be greeted. I welcome you. This is Elton from Maths and Science series. This is the continuation of the second part of trigonometry, which is the reduction formula. I hope you watched the first part, which is the trig identities, where we're proving them and simplifying them. If you haven't watched it, make sure that you watch it before examination. So our classes are at Phosphorus. So if you want to join in our classes, you can WhatsApp or call that number that is displayed there on your screen, where we are offering mathematics and physical sciences from grade 10 to grade 12. Do not forget to subscribe. Do not forget to share, like, and turn on the notification bell so that you can be alerted, you can be notified when you upload new lessons or new videos. Guys, even if you can just comment saying thank you Maths and Science series as your appreciation that we are sending you lessons that are explained in a better or easiest way or manner. Would appreciate that. Just say thank you Elton or thank you Maths and Science series. We will appreciate that. We'll appreciate that. And do not forget to share the videos to other people so that they can get the help. Alright, so we have special angles which you were taught in grade 10, which is 30, 45 and 60. These are the things which we're going to deal about since you're doing reduction formula, because the first thing that you must know that when we reduce our ratios or trigonometric ratios, we are just reducing them into special angles. So that is why I'll be studying with the concept of special angles, reminding each other of what special angles are. Now, special angles were 45 and 30 and 60, but now we will deal first, or we'll talk about the 45 special angle. So it is very important, listen to this very careful, because when we reduce, we are reducing into special angles. You were taught about the right-angled triangle. Right-angled triangle. Now here it is this 45, our special angle. So it is triangles of special angle 45. Okay, on the opposite side it is 1 and the adjacent side is also 1. So for the hypotenuse side, you use what? You use the theorem of Pythagoras to get it. Some other learners were asking, where is this root 2 coming from? So this is where the root 2 is coming from for the hypotenuse side. So remember, when we look for the hypotenuse side, we add what? We're summing the opposite side and the adjacent side. So here we substitute our x, which is 1 plus and the opposite side, which is also 1. But don't forget to put the exponent 2 there. Now our r squared equal to 1 plus 1. R squared equal to 2. For us to get the r, we need to do what? To get rid of that exponent 2 by putting a square root. So what you do on the left, you also do it on the right. Now r is equal to root 2. So this is how we have, this is the reason we are having root 2 as our hypotenuse side. So it's very important for you to know this, because when we reduce, I will repeat this, when we reduce, we are reducing two special angles. Alright, now we have everything, the hypotenuse side, adjacent, and the opposite side. So it's very important, because the teacher can see or can detect if you use a calculator. When they say simplify, whatever then they may say, you must simplify. So it is possible for them to do it, to get or to understand that you did what? Use your calculator. So special angles, actually you do not use a calculator when you simplifying them. So sine 45 is a special angle because we see the 45. Now we know that we get sine by the opposite of 45, which is 1, and the hypotenuse, which is root 2. Remember, SOHCAHTOA, opposite over adjacent. Sine of 45, which is 1 over root 2. You will see where this is going to. Now, so if you use your calculator, it is possible for us or for your teacher to see if you use your calculator or special angles. So now you have tan 45. Remember, SOHCAHTOA, on the last three words, it is TOA, T opposite over adjacent, which is 1. Which is 1 over 1. Then there we get what? We're getting 1. I don't know if you understand that, but I hope you understand it. So cos of 45. Now cos, it is what it is, adjacent over hypotenuse. So 45, when we do this, that's at the opposite, but we are interested on the adjacent, on the base side, which is 1 over root 2. Okay, so it is very important for you to know this. I'll remind you where this is going to help us. Now, special angles of 30 and 60. So 30 and 60, they go together. Now, again, we have what? A right angle triangle that is split, or that is splitted. Now, let me just fix this here. Then here we have angle 30, and here we have angle 60. Then here we have square root 3, here we have 1, then the hypotenuse side, it is 2. So you must know this right angle, or these special angles of 30 and 60 in this manner. So it is very important. Now they will say simplify sine 30. Now you must not use a calculator when we are dealing with special angles. Now sine 30 is 1 over 2. Remember, opposite over hypotenuse, which is 1 over 2 is the answer of sine 30. So if you use your calculator, sometimes you can see that it is possible that you get something that is not written as a half, but this is usually in 45. So if we have sine 60 plus cos of 60, now you use your special angle. Sine 60 is root 3 over 2. Remember, opposite over hypotenuse, which is root 3 over 2 plus the cos of 60, it is half, or 1 over 2. So sine 60 is opposite over hypotenuse, which is opposite over hypotenuse there. Now cos of 60, it is the adjacent over the hypotenuse. So you do the cross multiplication, then you get your answer. So it is very important for you to know how to use the special angles, or we are reducing our trigonometric ratios as we are doing as we are doing reduction formula. So we are reducing our trigonometric ratios into special angles. So that is why I started in special angles, reminding you guys of 45, 30, and 60. Now, you were taught in grade 10 about the Cartesian plane in trigonometry known as the cast diagram. So here we have the first quadrant, second quadrant, third quadrant, and the fourth quadrant. Alright, so it is very important for you to listen very carefully and understand what I'm going to explain here. So we call this Cartesian plane in trigonometry the cast diagram, or in reduction formula, the cast diagram. So that cast, that 4 letters, you put them, or each letter you put it on these quadrants. So the A here stands for all. It means that all trigonometric ratios, sine, cos, and tan, those trigonometric functions or ratios, they are all positive. in the first quadrant. Don't know if you understand that, but you'll understand it. Now the S, you put it on the second quadrant. That S doesn't stand for second but sine. It means that the sine function or the sine ratio, it is positive on the second quadrant, provided that the first quadrant, all of them, they are positive. Now on the third one, on the third quadrant, it is tan. That T doesn't stand for third but tan. So tan theta, it is positive, or tan ratio is positive on the third quadrant. Then here we have our cos, or we have our C. So it is positive on the fourth quadrant. So it is very important for you to understand this, because the first thing that you must understand, guys, when you're dealing with the reduction formula, it is what I'm explaining here. So if you didn't follow, just pause it and go back and watch it. All right, so the C stands for cos, which is the fourth quadrant, okay? Or cos tells us about the first quadrant. Now A, which stands for all, tells us about the first quadrant, that all trig functions are positive on the first quadrant. Now the S stands for sine. So this is cosine. Then the T stands for the tangent function. You can take it as third if you want. I don't know if you get it, so it can be easy for you to remember that T is on the third one. It means third, but it is tangent. S, it's second, but you know that it is what? It is the sine. Then A as the first alphabet, it is the first quadrant, which stands for all trig ratios. Then C, it is the cosine. Okay, now here's our Cartesian plane. And make sure that you listen very carefully, since you know that in trigonometry we're dealing with angles. So even on the cos diagram, we must have angles. So we have 0 degree here, or 0 angle. Then here you have what? The 90, and 0 plus 90 is 90. Therefore 90 plus 90, we get what? We're getting 180. Then 90 plus 180, we're getting what? We're getting 270. 90 plus 180, we're getting 270, which is the third quadrant. Okay, now 270 plus 90 will get 360. So it doesn't end here. You can add those 90, get to 720, or to whatever digit or value. It doesn't end on 360. Now here, since it is 0 to 90, we have what? The theta. That means that angles on the first quadrant, they are called acute angle, because they are angles that are below 90. So here it is theta. Now on the second quadrant, you say 180 minus what you got on the first quadrant, 180 minus the theta. So 180 minus theta represents the S, remember, or represents the sine. So here on the third quadrant, 180 plus the first quadrant, it is the theta. So this 180 plus represent what? The tan, or represents the T, remember, cast. Then on the third one, it represents what? 360 minus theta. So that 360 minus theta represents the cosine. Then on the first quadrant, it is also 360 plus theta. I don't know if you get that. Now here it is also 360 plus theta. Here it is 180 minus theta, 180 plus 360 minus, which is the cos. Now here it is 180 minus, here it is 180 plus 360 minus, and up there it is theta and 360 plus. Okay, for an example, they say simplify. Make sure that you understand what we'll be doing here. Focus. For an example, they say simplify sine 180 minus theta. The first thing that you must do, it is that you look what's inside the brackets. So whatever that is inside the brackets tells you about the quadrants. Don't know if you get that. So first look at what is inside the brackets. Don't focus on the trig ratio. So the things that are inside the bracket tells you about what, about the trig ratio. I mean, it tells you about the quadrants. So we know that on the second quadrant, sine it is what, it is positive. So therefore our answer is positive sine theta, because you close this and you look what's inside the bracket. So what is inside the bracket tells us about the quadrant, which is the second quadrant. And if I remove that marker, if I get that what is there, it is not sine theta, it will be that thing, but it will be negative. But if I remove and I get sine, it means that that positive sign, it will be, I mean that sign, it will be what, it will be positive. I don't know if you get that. But let us do the second one. For an example, you have 180 or sine 180 plus theta. Now let's say simplify it. Okay, the first thing for you to do, you close what? You close the trig ratio and look at what is inside the bracket. So what inside the bracket tells you about what, the quadrant. So that's quadrant number 3. If I remove that marker and I get that what's there in the marker, it's not tan, it means that it will be what, it will be that thing, but it will be negative because they placed it where it doesn't belong to. So sine theta on the third quadrant, it is negative. Why? Because we know that sine theta is positive on the first quadrant, I mean on the second quadrant and the first. So on the third it will be negative, but if it was tan there, it will be positive tan theta. I don't know if you understand that, but let's carry on. Now the third expression for us to simplify it is cos 180 plus theta. The first thing, you close what, the trig ratio. As you close the trig ratio, now 180 plus tells us about the third quadrant, and on the third quadrant what we have, it is tan to be positive. But now if I remove that marker and I find that it is not tan that I've hidden there, it means that it will be that thing, but it will change its sign. Don't know if you get that. So it will be negative cos theta. Why? Because we placed cos on the quadrant which cos doesn't belong into. So we'll have what, the negative of cos theta. Okay, now let's try another one. So it is very important, guys, for you to understand these things that I'm doing here. So tan 180 minus theta. The first thing, you close the trig ratio, then you look at what is inside the bracket. That tells you about the quadrant. It means that this the second quadrant. In the second quadrant, it is sign that it must be positive. So if I remove it and find that it is not sign there, it will be that thing, but now it will be what? It will be negative. So now we have what? Negative tan theta, because tan, it is only positive on the third quadrant, which is 180 plus theta, or plus whatever angle. They can use x, they can use a. So the fifth one, the cos of 360 minus theta. Cos 360 minus theta, it is on the fourth quadrant. Now I close the trig ratio. This is the fourth quadrant, and we know that in the fourth quadrant it is cos that must be positive. So if it is not cos there, it will be that thing, but it will be what? Negative. So now since it is cos, we are happy because our cos will be positive, because that's the quadrant where cos belongs. Don't know if you get that, but I hope that you're getting the gist of what we are doing here. That clue that you are having is very important, so make sure that you understand this clearly, because the reduction formula contains many marks. Now the 60th one, we have sine sine 360 plus theta. Now they say simplify it. Now sine in 360 or 360 plus, it is on the first quadrant, knowing that on the first quadrant all of them are what? They are positive, and sine is positive on the what? On the first and on the second. So since sine 360 plus, so we see we close what? We close the trig ratio, then we look at what is inside the brackets. It is 360 plus theta, and 360 plus theta is on the first quadrant. Therefore, all of them will be positive. That is why we having what? A sine of theta, or positive sine theta. Okay, now let me write this one here, tan 360 plus theta. Now we'll have what? A positive tan theta. Why? Because when we close here, we see that the brackets there, what's inside the bracket tells us about what? The quadrant. Now that's the first quadrant because it is 360 plus. So as it is the first quadrant, remember, cast all are positive. So we'll have what? Positive tan theta. So the most important thing is for you in the reduction formula to do what? To know your quadrants. So that's very important. Knowing the quadrants is you guys knowing what? Or understanding the reduction formula. So it is very important. The first thing, close the trig ratio, then focus or look at what's inside the bracket. Then after that, you remove whatever that you close that trig ratio with. Then after that, you do it, you conclude saying your trig ratios are positive or negative. All right, let's simplify this thing. Remember, the first thing, you close the trig ratio, deal with what's inside the bracket. Then after that, you conclude. Okay, now the first thing that you must do here, you know that 180 plus on the third quadrant. So you're doing what? You close the trig ratio. So 180 plus on the third quadrant, and the third quadrant, it is tan that is positive. So if I remove this and find that it is not tan there, it means it will be that thing, but now it will take a negative sign. Why? Because it is the quadrant that cos doesn't belong into. So we have what? Negative cos theta times, remember that there's a times there, but they didn't put it, but let me just avail it, or make it to be available there for you guys to see it, or let me just make it to do it to be visible. So 360 minus on the fourth quadrant. Now as I'm removing this, I must get cos so that it can be positive, but if it is not cos, it must be negative. So that is why I'm having what? Negative tan of theta. Now after here, you simplify. Now the negatives, they will multiply. You get what? The positive cos times positive tan of theta. Remember that we dealt with this in our trig identities. If you didn't watch it, make sure that you watch it, because here we're going to discuss something, a little bit of trig identities. Now we have cos of theta. Remember, we're not dealing with tan, but we must deal with what? We must replace tan with sine of theta over cos of theta. Remember the quotient identity. Now when we are here, there are things that can be cancelled. So here we can say over one side, we can deal with fraction both sides. Okay, this will cancel that one. Now we are left with what? With a sine of theta. So here actually we are just simplifying to a single trigonometric ratio. So the most important thing, make sure that you do what? You close the trig ratio, then conclude with their quadrants. Now we have sine 180 minus theta plus, let me just plus sine 360 plus theta. So the bracket tells you about what? They tell you about the quadrants. Now 180 minus the second quadrant, and we are hit that sine, it is positive there. So 180 minus theta, we have sine or positive sine theta. Then plus, now sine 360 plus, 360 plus is what? The first quadrant. We are interested with what's inside the bracket, so we'll have what? The sine of theta there. Now here we have, for an example, in algebra you were taught that x plus x is what? It is the 2x. Now even here still the same thing, there's 1 here, the coefficient there's 1 there, then do what? You add those one, then you take the sign as what? The common factor, then you sum, then you have what? 2 sine theta. I hope you understand this. So that's very important, that you do what? You close the trig ratio and focus on what's inside the brackets. So that's a reduction formula. That is how you simplify reduction formula expressions. Now they say simplify what you see there. The first thing for you to do is what we were doing all along, closing what? The trig ratio, focus on the brackets. Now there 180 minus, it's in the second quadrant, and we know that tan the second quadrant, it is what? It is negative. Then we'll have negative tan of theta multiplied by sine 360 plus, or 360 plus on the first quadrant. It's on the first quadrant, it means that sine there, it is what? Positive, because all three ratios are positive. 360 plus is on the first quadrant, therefore we have what? The positive sine theta. Then over cos 180 plus, 180 plus on the third quadrant, and cos third will be negative because it's in the quadrant which it doesn't belong into. Now we have what? Negative cos theta times 360 minus, that's the fourth quadrant. Now tan there, it is negative because it doesn't belong there, it belongs to the third quadrant. Now we'll have negative tan theta. I hope you guys understand this. Now here what we can do, we simplify until we get a single trigonometric ratio. So there we have negative tan theta, which can cancel. Then we are left with what? With the sine theta as what? As the numerator, and the negative cos theta as the denominator. Then this thing tells about the quotient identity, which is negative tan theta. Or even if you can say sine theta or negative cos theta and you leave it there, it's still fine. But even if you can continue with it, saying it's a quotient identity, negative tan theta, still fine. So the most important thing, focus on the bracket, because they tell you about what? The quadrants. That's very important. Alright, now we'll do what is known as cofunctions and negative angles. Remember, we're doing a reduction formula of angles 180 plus or minus theta and 360 plus or minus theta. But now we'll be dealing with cofunctions. Then when we deal with cofunctions, we are dealing with angles of 90 plus or minus. Remember, we're dealing with 180 plus or minus, 360 plus or minus. But when we talk about cofunctions, we are talking about 90 plus or minus. Then the negative angles, you will see this thing of negative angles, for an example, sine negative theta. So that's what we'll be talking about. Don't stress much, it is easy. You'll see how we are going to approach, or how we're going to do it. But make sure that you focus, and understand what we were doing, the reduction formula, or where we were simplifying before this part of cofunctions and negative angles. I hope now you understand the reduction formula of what we were doing before these concepts that we are in, cofunctions and the negative angles. All right. So I drew a Cartesian plane here. So we are discussing about cofunctions. Now it's very important for you to know these cofunctions. Here we have the the 90 minus, which is the first quadrant, and the 90 plus, it's on the second quadrant. So we only have these two cofunctions there, on 90 plus on the second and 90 minus on the first quadrant. Okay, so we have four of them. Four of the cofunctions which you must know. It is very important. Okay, so sine 90 plus, okay, sine 90 minus, and again we have sine 90 plus, and we have cos 90 minus, then cos 90 plus. We don't have tan 90 minus or tan 90 plus, so let's focus on these four. All right, now when we have the cofunctions, what you need to understand, since we have sine here, what you must understand is that the cofunctions changes. So if we have a sine 90 or sine 90 plus or sine 90 minus, it will change into the cos of that angle. So here we'll have what? Positive cos theta. So cos is always positive. It is only negative in 180 plus or minus, but in all the angles or in all the quadrants, it is what? It is positive. So here we'll also have cos and cos theta. Why? Because we are talking about the cofunctions here. So cofunctions, they change the trig ratios. You get that? Now here we have cos 90 minus. Cos 90 minus, it will be it is on the first quadrant. So cos 90 minus, it is on the first quadrant and this on the second quadrant. But what you need to understand, it will change into positive sine theta. You must know this is very important. 90 plus, and there we have cos, we'll have what? The negative sine theta. So you must know this as I am showing you here. So you can go and ask your teacher, why are they changing? But focus, you must know that it is changing because you're dealing with what? The cofunctions. So that's very important. That's very important. Make sure that you know what I've written there. Okay, let's just do the first example that have cofunctions. So I have cos 90 plus theta times sine 90 minus our plus theta over can use sine 180 plus theta. Now what you need to do is just you remember your quadrants, cos 90 plus on the second quadrant, and there we have what? Negative sine theta. So cos 90 plus theta, you replace it with what? With negative sine theta times we have we have sine 90 plus, and it's also on the second quadrant, which is the positive cos theta. So this is similar to reduction formula. So I won't do much of them, but this is what you must know. This the third quadrant, and the third quadrant sign is negative because it is not in its quadrant. Therefore negative sine theta, divide the negative sine theta. We are only left with the cos of theta. So the most important thing here, make sure that you know your cofunctions. Make sure you know those four, summed by the reduction formula which we did. Now, let's check 2 sine 90 minus x plus sine 90 plus x over sine 90 minus x plus cos 180 plus x. So try that one on your own and see if you get it. But I trust you guys that you are going to ace this one. So the first important thing, make sure you know your quadrants and cofunctions. Now, negative angles. So here we'll be dealing with negative angles that are negative. So suppose you have a sine of a negative angle, which is sine of negative theta, and you have the cos of a negative angle. So that theta is an angle. Remember, I've discussed that with you guys on trig identities. So tan negative theta, and these are negative angles. So what you need to know about negative angles is that negative angles are on the fourth quadrant. That's very important for you to know. Now, this is what you must do. If you have a negative angle, you sum it with 360 or you add 360. This is what you must do. Make sure you understand this. Now, for an example, 2 plus 1 or 1 plus 1 is still the same thing as 2 plus 1. So write negative theta plus 360 in another form, but must not be different to that format. So we have sine, which is 360 minus theta. So you see that this thing is on the fourth quadrant, and sine on the fourth quadrant, it is negative. So the sine of a negative angle equal to negative theta, negative sine with whatever angle that they place there. So it will be negative sine theta. So here we know that negative angles are on the fourth quadrant, therefore cos theta on the fourth quadrant, it is positive. But if your teacher asks you why are you saying it is cos positive, you just write this negative theta, you sum the 360, then cos 360 minus theta. Now you know that cos is positive on the fourth quadrant, and on the fourth quadrant we have what? We have 360 minus theta. So just do that third one there, and your answer must be negative tan theta. Why? Because negative angle is on the fourth quadrant, and on the fourth quadrant tan will be negative. So we'll have what? Negative tan theta, as what we heard when we're dealing with sine of a negative angle, or sine negative theta. Okay, now the first example, say simplify cos 90 plus theta times sine 90 plus theta over the sine of a negative angle, which is negative theta. Then here it's our cofunction, it will change. Remember, we'll have negative sine theta. Make sure you know the cofunctions. Times, we have sine 90 plus, it will change into a positive cos theta. Cos is always positive, but it is only negative in 180 plus or minus. So here we have what? Negative sine theta, and we know that we have what? Negative sine theta. So our answer there, it will be negative sine theta. because it is on the fourth quadrant. Therefore, these cancels. Then we are left with the cos of theta. Don't know if you understand that, but that's very important, that the negative angle is on the fourth quadrant, all of the negative angles. All right, now we were dealing with 180 plus, 180 minus, but now we'll deal with, for an example, they give you numbers, not those angles we're dealing with on the Cartesian plane. For example, sine 90 plus, 90 minus x, 90 plus theta, but now we'll be dealing with a number. So what do I mean when I say we're dealing with numbers? For an example, sine 1, for an example, they say simplify sine 150. So you see now this is a little bit different, but still the same thing. So for an example, let's say simplify this. What you need to understand first, it is that 150, is it above 180 or below 180? So what you need to do is say sine, then 150, it is below 180. So you say 180 minus. So 150 is on the second quadrant. 180 minus 180 minus what? Minus the number that they subtracted from 180 to get that 150, which is minus 30. I don't know if you get that. So 180 minus 30, it's on what? The second quadrant. And on the second quadrant, sine, it is what? It is positive. Therefore, as sine, it is positive on the second quadrant, we'll have what? Sine 30, or positive sine 30. And you see that 30 is a special angle. Remember, I said that when we reduce, we are reducing our trigonometric ratios into special angles. So we see 30 there. You draw the 60 and 30 right-angled triangle or special triangle. So that's very important for you to know. You must not use a calculator here. Now they will say simplify without the use of a calculator. So we must use what? Special angles, because you see sine, because you see 30. Now sine 30, it is what? It is half. So it is very important for you guys to know this. The most important thing, you just check if that number is below 180 or above 180. Then as it is below 180, it is 180 minus. 180 minus the number that they subtracted from 180 to get 150, which is 30. I don't know if you get that. The second example, let me say you are given 163. The first thing again, 163, is it 180 plus or 180 minus? It means that it is 180 minus. So it is on the second quadrant. I don't know if you get that. So sine 180 minus what number they subtracted to get what? 163. So it is what? It is 17. And 180 minus 17, it is on the second quadrant. Therefore, on the second quadrant, sine, it is positive. Therefore, we'll have positive sine 17. You see that, right? That's very important. Let's try another example. Now, tan 300. So tan 300 or 300, is it below 360 or above 360? So it is below 360. So it is 360 minus. It means that tan 300 is on the fourth quadrant. So what number did they subtract to get 360 from 3? To get 300 from 360, it is 60. And 360 minus on the fourth quadrant. Therefore, tan on the fourth quadrant, it will be negative. I hope now you know this. Now we have 60 there. It's a special angle. So we need to use what? The triangle there, or the special angle. So here our answer, it will be negative. Then tan, which is root 3 over 1. Therefore root 3, it's our answer. Then you get rid of the brackets. You get negative root 3 as your answer. So we are reducing to special angles. I hope you are now getting the clue or understanding what we are doing here. All right, now cos negative 213. This is a negative angle, and we know that negative angles, they are on the fourth quadrant. Therefore, cos, it will be positive 213 because cos it is positive on the fourth quadrant. Now 213, is it above? Is it 180 plus or 180 minus? It is 180 plus. Why? Because that number is above 213. So what digit or what number did they added to get 213? So it is 33. Therefore 180 plus, it is on the third quadrant, and third quadrant cos, it is negative on the third quadrant. Therefore we'll have negative 33 as our answer. Negative cos 33. Sorry, I hope you understand this. So that's very important. That's very important. Okay, determine the value of the following without the use of a calculator. So when they say without using a calculator, it means that you must use what? Special angles. So sine negative 30, that's the fourth quadrant, because we're dealing with a negative what? A negative angle. Remember I told you about something minus 30. So you add what? You sum the 360 there, then you say sine 360 minus theta, and you see that that's the fourth quadrant, and sine there must be negative. So that is why we'll have what? The negative sine theta. Get that? Over tan 150. Now tan 150, it's on the second quadrant because it is 180 minus. Let me just okay, 150, it is below 180, so 180 minus. What number did they subtract from 180 to get 150? Remember we did this. It is 30. Okay, plus cos. Now 330 is 330 minus, right? Because it is below 360. I mean, it is 360 minus. So 360 minus what? Minus 30, because they minus or subtracted 30 from 360 to get 330. Therefore here you use what? Your special. You use there's no need for me to continue writing negative sine theta. I mean 30, you need to draw what? Your right angle triangle with a special angle of 60 and 30. Then there it is root 3, here it is 1, then the hypotenuse side, it is 2. Therefore negative sine theta, when you use that thing, you will have 1 over 2, which is 1 over 2, but it must be negative, remember. Now below there you have 180 minus. 180 minus on the second quadrant. Therefore tan on the second quadrant, it is what? It is negative. Then for we have negative tan theta. Don't know if you get that, but that's very important. Make sure you pause the video and listen again to what I was explaining there. Now 360 minus, it's on the fourth quadrant. Therefore we'll have what? Positive cos theta. Why did I put that bracket? It is because sometimes you can get a negative sign there and you're not aware that but I hope you understand what I did then. Okay, now tan theta, it is what? It is 1 over root 3, but it must be negative. Then this times this is what? It is positive. You will see that each of the brackets there on the next example. Plus cos theta, it is what? It is root 3 over 2, because root 3 is our adjacent side. Root 3 over 2. Okay, on your left you have negative 1 over 2 over negative 1 over 3. we don't write it in that manner, but you must not use a calculator. They say without using a calculator. So this is what you must do: multiply by, or you do what the reciprocal of the denominator, which is negative root 3 over 1. Then you multiply the numerators and the denominators. You have what? You have positive 2. All right. Now you have root 3 over 2 plus root 3 over 2. Then you do the cross multiplication there. You get 2 root 3. And you get 2 root 3 there also. Sorry, it is root 3, yeah, over 4. Then do the math, you continue with it. I will just leave it here for you. Just continue with it. The common factor, then after that you simplify, you do the math. But if you didn't get root 3, you must know that you are wrong. Alright, so 1 minus cos 30 and multiply by 1 minus cos 210. So this is the same thing again. 1 minus, what is the cos 30? Oh, this is special angle. So you draw your right angled triangle. You are not using a calculator, so the purpose of special angles, or their main aim, help us not to use what's the calculator. So cos 30, it is what? It is root 3 over 2. 1 minus cos 210. So 210, it is 180 plus, because it is above 180, right? So 180 plus what? 180 plus 30. Now 180 plus 30 is what? Okay, let me just put another brackets there, or let me just rather put the square bracket even here, the square bracket, so that we can differentiate between the brackets that are inside and the square ones. Over 1, do cross multiplication here, these times that, it is what? It is 2 minus root 3 multiplied by 1, which is root 3 over 2. 1 times 2, it is 1. And I put my brackets here. Now I have 1 minus, now I put another bracket, therefore the sign that I will get, which will be negative cos 30. So I hope you see now the importance of putting the brackets when I'm substituting my answers from cos 180 plus 30. Now here I have 2 root 3 over 2, then 1, this times this, it is positive, right? Now the cos of 30, we have positive cos 30 there. Now 2 minus root 3 over 2, you put the bracket, remember 1 plus cos 30. What is cos 30 from a special angle? Still the same thing that we got here. It will be positive what? Root 3 over 2. And if you get that, all right, I don't think I'll finish this one. I will leave it for you guys to do the math on the last step of getting the answer. So over 2, right? Even here we need to do what? We need to cross multiply. This is the same thing. So we have 2 plus root 3, y plus root 3 over 1 when cross multiplying. Then here we have 1. Then continue with it and get your answer there. So that's algebra. I hope you know how to continue with that expression there, multiplying the denominators and multiplying what again? The numerators, then get your answer. All right, I hope this is the last one because actually I'm tired. Okay, tan 300. 300 it is 360 minus, because 300 it is below 360. So 360 minus the 60, right? The one that is subtracted from 360 to get 300. So we minus the 60 times cos 120 minus 60, because 120 is below 180, so it is on the second quadrant, so it is minus 60. I hope you now understand this. Now 360 minus on the fourth quadrant. Now turn on the fourth quadrant, it is what? It is negative. So negative tan 60 times cos on the second quadrant, it is what? It is negative, was that 180 minus. So we have negative cos 60. Therefore, when we multiply, because we have like signs there, we'll have tan 60 multiplied by cos 60. Remember, negative times negative give us positive. Now here we have tan 60 and the cos 60. Those are special angles. So you draw what? Your right angle triangle with those special angles there. Then here we have 30, and tan 60 you have what? 3 over 1. 3 over 1, opposite over adjacent. Remember, 3 times cos 60, which is half. Now you get what? 3 over 2 as your final answer. Okay, so the most important thing, make sure you know your quadrants and special angles, how to use the special angles. Try to do this one on your own. It is 8 marks. So make sure you understand your quadrants, the cofunctions, and negative angles. So that's the key for you guys to understand this. All right, thanks for watching. Do not forget to subscribe.